Okay, so we come back again and start the same problem that we had left. In this particular problem, why I have taken this particular problem is so that you can know how to find out y bar, how to find out moment of inertia, and then how to solve this particular problem, because it is not having a standard loading, right? It is a overhanging beam subjected to a point load at the free end. So all these things are different from what we have done in the previous problems, right? So to start with, first is I have told you that we have to put our section in such a way that it should be lying in the first quadrant. So it is lying in the first quadrant. Now we have to prepare one table. So to prepare one table, what we are doing, we will try to have a standard shape. After having standard shape, we will have area of that standard shape. Then we will have so the first will be standard shape. Okay, second will be area of standard shape. Third will be distance of standard shape with respect to reference axis. Okay, so we start with the first. So first is a rectangle. So we can show a rectangle. Okay, what are the dimensions of a rectangle? 100 and this is 20. So what will be the area? A1, that is equal to 100 into 20. Okay, that is 2000 mm square. Okay, now where is the reference axis from first section? So somewhere over here we have got x-axis. What is this distance? That is 100. Okay, what will be the CG of standard shape? Intersection of diagonals, that is equal to, this will be d by 2. So this is nothing but d by 2. Okay, so what is the y1? So y1 is distance with respect to reference axis. This whole will be your y1. Okay, so y1, that is equal to 20 divided by 2 plus 100, that is equal to 110 mm. Okay, then we come to the second. So second is a vertical rectangle, right? And what are the dimensions of vertical rectangle they have given? This is 100 and this is 20. Okay, so what will be the area? So area A2, that will be equal to 20 into 100, that is again 2000 mm square. Okay, and what will be y2? So y2 is intersection of diagonals, and where is our reference axis passing? This is our reference axis x. So that is nothing but d by 2, that is 100 by 2, that is equal to 50 mm. Okay, so now what will be y bar? So y bar, that was equal to a1 y1 plus a2 y2 upon a1 plus a2. Okay, so we can put all the values and we'll get the value of y bar as 80 mm. So we get y bar, that is equal to 80 mm, right? So first step is over to find out the position of neutral axis. Okay, so we can show over here that in our diagram neutral axis is lying somewhere over here. Okay, and I can pass neutral axis from this particular point. So this is neutral axis Okay, this I can write down as y from bottom, and that is nothing but 80 mm. So what will be y from top? What will be y from top? Total is 120. So 120 minus 80. So y from top, that will be equal to 40. Okay, so this we have calculated. Now we come to the next part, that is we have to calculate the moment of inertia, right? Now to calculate the moment of inertia, again we have to prepare our table. Okay, what is that table? First is standard shape, that is standard shape. You can even continue in the same table. Second is area, or I can say moment of inertia. I am writing it as MOI, moment of inertia of standard shape. Okay, that is represented as IG. Then third is area A. Then fourth is distance between CG of whole section, that is y bar, and CG of standard shape, that is y1 or y2 or so on, that is equal to nothing but h, that is equal to y bar minus y, where y is equal to y1, y2 and so on. Okay, and the last will be Ixx, that is equal to Ig plus AH square. Okay, so this is our table for moment of inertia. Okay, I think you are able to see. Yeah. Okay, now we start with our first shape. So the first shape is rectangle. Okay, what are the dimensions given? 100 by 20. So moment of inertia is BD cube by 12, that is equal to 100 into 20 cube divided by 12. Then area is 100 into 20. Then H1, that is equal to y bar. What is y bar? We have calculated 80 minus y1. What is y1? 80 minus y1 we had calculated as 110. So that is equal to minus 30. Okay, put all the values over here. So you'll get Ixx1, that is equal to 1.86 into 10 to the power 6. Okay, then we come to second is vertical rectangle. Dimensions are 20 by 100. So BD cube by 12, that is equal to B is 20, D is 100 cube divided by 12. Okay, area 20 into 100. H2, that is equal to y bar minus y2. Y bar is 80, y2 is 50, we have calculated. So that is again equal to 30. So you get Ixx2, that is equal to 3.46 into 10 to the power 6. Okay, so therefore Ixx, that is equal to Ixx1 plus Ixx2. Okay, Ixx1 plus Ixx2. Now that will give you the answer as 5.32 into 10 to the power 6. What will be the unit? mm to the power 4. Okay, so this is you have calculated the value of moment of inertia. So second step is over. Now what is our third step? So the third step is we have to calculate the value of maximum bending stress. So third step, F beam. Now I'll first write on what we have calculated till now. Y bar bottom, that is equal to Y bar bottom, that is equal to 80 mm, which we have calculated. Fourth, we have calculated Y bar top, that is equal to 40 mm. Then we have calculated fifth, that is moment of inertia Ixx, that is 5.32 into 10 to the power 6 mm to the power 4. Then we have been given the value of FBC, that is 70 megapascal, or I can say 70 Newton per mm square, and FBT, that is equal to 40 megapascal, that is equal to 40 Newton per mm square. Okay. Now we are interested to find out the value of moment. So moment M, that is equal to what, right? So now we'll come to the loading of the diagram. What is the loading of the beam given? They have given a beam like this. Okay, they have given a beam like this. Okay, then what they have given? A point load of intensity W. This is 1 meter. This is 2 meters. Okay, and this is, suppose I name it as A, B and C. Now I want to calculate the value of bending moment. So before calculating the value of bending moment, I have to calculate the value of reactions, right? So the first step is reaction calculation. Okay, sigma V is equal to 0. So RA, RB is equal to W. This is equation 1. Second is sigma moment is equal to 0. So moment about A, we get W into 3. Okay, clockwise positive, minus RB into 2 is equal to 0. So 2RB is equal to 3W. So RB is equal to 3 by 2W, that is equal to 1.5 W kilonewtons. Okay, so RB is equal to 1.5 W kilonewtons. That we have calculated, right? Now we want to calculate the value of moment. So moment, which moment? Bending moment, because I want maximum value of moment. So we know that bending moment at point C 0, bending moment at point A 0, but bending moment at point B, what it will be? Bending moment at point B, that will be equal to W into 1 meter. So that is W kilonewton meters. So we have calculated as M is equal to W into 10 to the power 6 Newton mm. Okay. So now if I want to calculate the value of what we want to calculate the value of W, we can use our equation. What is our equation? FB is equal to M Y upon I. What is the value of FB? 7. Now important part, when I take FBC, compression. So where will be the compression? Compression will be at top. So I have to take Y top. What is FBT? 40 megapascal. So when I take this, I have to take Y at bottom. Okay, and get the value of MR. Okay, so we find out the value of MR. MR is nothing but moment of resistance. So that we will calculate. So FB that is equal to M Y top